All right, can you guys see my screen?
Yeah, we could hear. We could see your screen.
Okay, so we're gonna get started now. Before we get started with the lab, there's a few announcements I gotta make. Really quick. Chapter 13, its lecture is up already. From what I understand, Dr. Henry won't be having lecture tomorrow morning, as he's pretty busy right now with something. So, uh, this week's lecture is already uploaded, and it's under modules, like always. It's right here, structure and shape. So that's this week's lecture, and important dates to remember is that so the plan is for this Saturday for the exam to go up, and I believe a practice exam is in the works as well, and that should be going up sometime this week. Um, this next exam is going to be covering chapters 1, 2, 3, 5, 11, 12, and 6, I believe. Another thing about the exam is that you guys are actually allowed uh, a cheat sheet this time around. It's one page, it's front and back. As to what you can put on it, that's entirely up to you. Any information that you want can go on that cheat sheet. I recommend putting concepts that you're still struggling with. That's what I like to do when I have one of these. Um, you're also allowed your packet for this exam. So you have that and a cheat sheet to go along with it. Um, and I think that's it as far as announcements. You guys have any questions? You guys feeling ready for the next exam? All right, nice, ready. So this today's lab, it's molecular modeling and Lewis structure. So it's right here. Let's go ahead and open that so we can get started. So it's actually not that many materials this time around. Um, I think the main thing from the kit that you need is the modeling kit, and it's really just like a bag, and it kind of looks like a bag of marbles. That's what we're going to be using today. And this also coincides with the lecture of chapter 13, I believe. So real quick, who didn't do the exploration? So everyone did it? Okay. So I guess everyone did it. That means we could get started with the first page. Um, Actually, I'll read the overview first. So what we're going to be learning today is Lewis structures for molecules. We're also be creating VSEPR models. using the kits, understanding valence electrons for elements, resonance structures, and being able to classify models ranging from linear, bent, trigonal planar, trigonal pyramidal, tetrahedral, and these last two, bipyramidal and octahedral, um, I don't think will be covered in the exam, but it doesn't hurt to know them, especially if you're going to go into Chem 1. So let's get started. Oh yeah, just a heads up, you're going to be taking a lot of photos in this one. It's a very photo heavy lab. See 1, 2, and then on the next page, going to be going up to 20. So that'll be fun. So this chart right here, table one, it actually is helps it actually helps label the little marbles and what they represent. So the white the tiny white ones are considered hydrogen, and make sure you don't confuse those with the larger white ones that have like 6 holes in them. The single bonds are represented by these tiny sticks. I don't have a camera, but I can draw, and they kind of look like that. I don't know if you can see the tiny drawing on the corner, but that represents a single bond, while the longer version represents a double bond. And there's these pink paddles that represent lone pairs. So, can anyone tell me what a lone pair is? Or any idea what a lone pair is? So let's see. Let's say we have an atom X, and it's being bonded with another atom, and there's these lone pairs, these valence electrons represented by the dots. This would be considered a lone pair. And on the models, that's what the paddles are. We use that to represent lone pairs. Um, and I guess just to show, this is a single bond. And if we add another line, that's a double bond. But I'm sure I'm just regurgitating what was told in the exploration part. But just a quick refresher. So here at item number 3, it says practice describing the molecular structure of the format of CHO2 minus, and then answer the following questions. So let's start off by building this and use the table up ahead above as a form of uh, as a way to know which balls to use. So carbon, we're gonna use a black with 4 holes. Hydrogen is again the tiny white ones with a single hole on them. And hydrogen, or I mean, oxygen is the red ones. So in this case, carbon is going to be our central atom. And we're using two oxygens, not hydrogen. So what should our model look like? Or I guess let's backtrack first. F how many of you, um, for how do I say this? Is this a new concept to you guys? Like, is this your first time looking at it? At structures and electrons. Okay. So let's backtrack a little. If it's not your first time listening listening to this, feel free to work ahead. But I'm gonna pull up a periodic table. Here we are. So let's look at carbon. Here's carbon. And carbon is in the 14th group, meaning there's a specific amount of electrons that it can share, or it has. I mean, I'm getting ahead of myself. So, a general rule of thumb that I like to use is that this first group has one valence electron. The second group has two. And we like to skip the transitional metals. I don't know why. I didn't make up the rules. So this 13th group has three. 14th, four. 15th, five, six, seven, and eight. So each group is trying to be like the noble gases. So carbon has one, two, three, four. So it's 4 away from having 8. And one way uh, atoms can reach the 8 is by sharing uh, electrons with other elements. So reaching 8 is what's called an octet. So something like neon. Neon has 8 around it, and it's good. Elements like to keep or have 8 valence electrons around them. Um, does that make sense so far? Pretty simple. Nothing crazy yet. So let's look at fluorine. Fluorine has 7 on its own, and it wants to reach octet 8. Uh, which element would it be a good uh a good bond for fluorine? If it wants to reach 8. Hydrogen, because hydrogen only has 1. So when these two come together, it forms a single bond. Fluorine has 8 now because this bond counts as 2. So we have 2, 4, 6, 8. Fluorine has 8 around it. It's reached octet. It's happy. So one exception to this is, of course, hydrogen. So we notice hydrogen doesn't have 8 around it. And that's fine because hydrogen only needs 2 valence electrons. Hydrogen cannot have more than 2. That will never happen. Hydrogen will never have more than one element attached to it. If you do somehow have more than one attachment to hydrogen, it's wrong. So keep that in mind. So how are we feeling on this so far? Should we try another one? Let's try a few more and then we could get back to the lab itself. So let's try probably the most famous molecule, H2O. So I like to count how many electrons each element has before I do my structure. So oxygen has 6, hydrogen has 1, but we have 2 of them, so 1, and we have a total of 8. So let's take our oxygen. And remember, um, Hydrogen only wants two electrons and it never has more than one attachment to it. So here's our two hydrogens. Let's count. 2, 4, 6, 8. Oxygen has its octet. Hydrogen has its two electrons. Hydrogen also has its two electrons on the other side. Everyone's happy. That's our structure. Everyone with me so far? All right. Let's try something more complicated. Let's try CO2. How many electrons does carbon have? So carbon has 4. Oxygen has 6, but there's two of them. So we have a total of 16. So a general rule of thumb when it comes to structures like this, carbon likes to be the center atom. The reason this is because it's in that sweet spot of 4, and it usually tends to bond with most elements. So it's always safe to have carbon in the middle. Now we have an oxygen on each side. Remember, oxygen has 6. So actually, I'm getting ahead of myself again. I gotta cool it. So 1, 2, 3, 4, 5, 6. So we draw our bond. However, what's the issue here? If you would have to take a guess what's wrong with this structure, what would it be? None of these elements are in octet, so no one has 8 around them. And that's an issue because if you don't have 8 around each uh, atom, it means it's not stable. So the thing is, though, we can't just make electrons. We can't make them appear out of thin air because that's just not how it works. There's like that saying, like you can't create or destroy. So we have to work with the 16 electrons that we started with. And we have to make sure each atom has reached this octet. So we already have single bonds here. One way we could go about this is by using double bonds. So remember, a single bond is consistent of two electrons. Any guess what a double bond would take up? So we're going to take this electron over here and this electron from this carbon and make them bond. And we're going to take this other valence electron and the other single from the oxygen and make them bond. So in the end, our structure would look something like this. So when we count, let's see what it adds up to. So double bonds count as 4 electrons. So these are 4. So 4, 8. Around this carbon, its octet is full, it's satisfied. So 4, 6, 8. Around that oxygen, its octet is full, and it's the same thing on the other side. 4, 6, 8. Each atom has 8 around it. Everyone's happy. And everything works. Questions about this one? Anything confusing about CO2? Okay, let's try one more example. So one more thing to teach you, and we'll head back to the lab. So let's take a look at this. Or wait, that doesn't make sense. All right. Yeah, that works. So who remembers from week 1 what electrons are? What's the charge of an electron? So electrons are negatively charged. Does that ring a bell? I hope so, because this example has a negative charge to it. So anytime you see this, that means there's an additional electron, Jesus, to the structure. And I'll show you what I mean by that here. So nitrogen, let's add up our electrons. Nitrogen has 5. Oxygen by now we should know has 6. And there's 2 of them. And now this electron is going to add on to the total amount that we have. So we should have a total of 18. I remember how to do math. 18 electrons to work with. So let's build our structure. So in this case, nitrogen will be in the middle. And then we have our 2 oxygens. And let's draw out. Let's create a bond here. And let's create one here. So is our octet full? The answer should be no. So let's try to find a double bond somewhere. So one thing we could do is attach this lone electron from the left oxygen onto this lone electron on the nitrogen. And then we could do this one on the right to this one. So in the end, we have does that look right? No, this nitrogen still has a electron left over, and it doesn't complete octet. It actually exceeds it, and that's not correct. You can't have 9 electrons on an atom here. And if we count, we don't have the total amount of electrons that we're supposed to have. I believe there's only 17 here. So 2, 4, 6, 8 plus 8, 16. And this lone one makes it 17. So remember, this charge on the initial structure, it has to be accounted for. So we're going to add it onto our structure, and we work it so it fills octet. So what I did here was I got rid of this double bond, brought it back to a single, and we took that charge, the excess valence electrons, and added it onto the oxygen. And now if we count, everything should work. So 4, 6, 8, 2, 4, 6, 8, 4, 6, 8. So every time you have this charge on that structure, it's it's accounted for. We don't just get rid of it. We add on to it. But there's one last thing that we have to do. I'm just getting rid of these arrows first. To show that there's a negative charge onto the structure, we add brackets and the charge that it's associated with. If you see this charge on the initial question, remember to bring it to the final structure. This would mean it's correct. If you don't have the charge in brackets, it's considered wrong. So, how does everyone feel on this short lecture? Is everyone ready to start lab? Okay, I'm gonna clear the screen and then we can go back to the lab. I'm just checking something really fast. Okay, I lied. One last thing. Last thing. I promise. So we just had a negative charge on the last structure. So what do you think this plus means? If that negative means we're adding on an additional electron to our final structure, what does the positive mean? It means the opposite. Shocker. I know. So let's count however many we have here. So we have hydrogen, which is 1. And we have 3 of them. And now we have the oxygen, which is 6. 6 valence electrons. And this positive. So for this positive, what we like to do is a -1. You're subtracting. You're removing an electron. Or a better way to say it is like this structure has 1 less electron. It's a cation. So we add everything together and it's 7. Or it's 8. So let's build our structure. Oxygen will be in the middle in this case, because remember, hydrogen doesn't like to have more than one thing attached to it. 2, 4, 6, 8. Octet is reached. Since it's charged, to put our brackets. And there we go. That's hydronium or H3O plus. Okay, now we can start. We can start for reals this time. All right, now that we know what we know, we can build CHO2 minus. So take a minute to build the structure. And remember, the long ones are considered double bonds. And don't forget to add the lone pairs. So let's look at number 4 here. Determine the number of valence electrons in the structure. So let's take so just like the examples I showed before, let's count our valence electrons. So carbon has 6 plus the 1 hydrogen, or I'm lying. I guess I forgot already. Carbon has 4, hydrogen has 1, oxygen has 6, and there's 2 of them. And remember the charge. So what should our total be? $18. So here, spend 18. All right. So now we want to draw the Lewis structure on a piece of paper. And then you guys are going to take a photo of it and submit it onto photo 1. So let's draw this. Carbon in the middle, like always. And we have a 4 around it. We have a hydrogen. And then we have 2 oxygens. Remember, we have a charge, so we have an extra valence electron. Most of the time, like a general rule of thumb, most of the time when we have this charge, it means that we're going to be working with at least one double bond. So that's one thing to keep in mind. So let's create bonds here. That's horrible. One here, and then we'll do one here. So no one's octet is satisfied here. So let's try to work a double bond somewhere. And remember, we have one electron left over on this carbon. So we can probably use it on this oxygen here. And then we could use this remaining charge and just add it onto the other oxygen. So our finished um, structure should look like let's count 2, 4, 6, 8, 4, 6, 8, and then remember hydrogen only 2. We count the total 2, 4, 6, 8, 10, 12, 14, 18, which works with the amount we're working with. However, I'm not done. This is a charged structure, so brackets. So this is the Lewis dot structure of this molecule. Pretty easy, you guys say? So let's continue on here. So now it wants us to build it, if you haven't done so already. I'll go ahead and draw what it looks like built. Um, my carbon here. My hydrogen. And my 2 oxygens. And remember, don't forget the lone pairs. So kind of looks like so does everyone know where I got the lone pairs from? I mentioned it briefly in the beginning. So just a quick reminder, electrons that aren't paired to anything, that's a lone pair. I'll just write LP because I'm on a mouse. Now I want you to take a photo of your structure and put it on the set photo number 2. So does the central atom have any lone pairs? So does this carbon here have any lone pairs attached to it? Oh, the answer should be zero. Does everyone understand how I got that? Okay, good. All right, number 11. Identify the molecular geometry around each central atom. Refer to figure 11 as needed. So, judging by this table here, which one would you say best represents the structure we built? So we have one central atom and three things attached to it. So it looks a lot like trigonal planar. What if we remove the hydrogen? Which one would it best represent the structure? So probably linear. I'm not taking account the central atoms that would be left if I remove the hydrogen. This is just a whatever situation. So does everyone understand how I got trigonal planar? What about H2O? So remember when we drawed it as an example? Is it linear or bent? It's actually linear because of these lone pairs. Or it's actually bent because of the lone pairs, not linear. Oops. So yeah, these green bubbles represent lone pairs. Okay. So here it says, when you're comfortable with your answers for the previous step, click here for the correct answers, then carefully read why the correct answers are they are and compare them to your responses, just to work if needed. So this is what it should look like when drawn. Oh, that's how you do it. That's funny. So I guess you're supposed to have two long ones on the structure and not just a single long one. And then trigonal planar. All right, so let's move on to the next page. I'm gonna clear that screen if it's okay with everyone. All right. So in this exercise, you will draw Lewis structures for a series of molecules and create the VSEPR model for the molecule using the model kit. So more of the same. I don't know why they didn't show this picture in the first page, but that's fine. So you will calculate the number of valence electrons, draw the Lewis structure, build and photograph the model, upload the image, list the number of bonds and lone pairs surrounding the central atom, and identify the structure, or if there's multiple, for each central atom. So let me just take apart my structure really fast here. I think the list of which ones you're going to build are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, 18 total structures. I'm not going to do all 18 of them, as I want you guys to do most of these on your own so you can learn. I will go over a few of them. And then after that, I'll let you guys go. But first, do you guys have any questions? Any whatsoever? Okay. If I'm moving too fast, just feel free to stop me. Or if you have a question that comes up later, let me know. So which one's the first one? Carbon tetrachloride. So let's do this one. So step one, count the total number of valence electrons and record the data. Table 2. So carbon has 4. And chlorine has how many? 7. I totally didn't forget there. And we have 4 of them. So 7 times 4 is 28. Plus the 4 gives us 32 electrons to work with. Or this is the total amount of valence electrons we have. So now it's time to draw the structure. So again, carbon in the middle. I'm getting ahead of myself. I need to stop doing that. And let's draw chlorines. 4 of them, each having 7 electrons. And then carbon has 4. So this one's kind of a no-brainer of how we should pair everything. And then let's count. So 2, 4, 6, 8. Looks like carbon is each octet, which is what we want. And then 2, 4, 6, 8 on the chlorine. And because the rest of the chlorines are the same, we can use the assumption that each of them have 8 around them. And in total, it looks like we do have 32 electrons around, or we use 32 valence electrons. So this is what the structure should look when it's drawn. So now let's go ahead and build it. And once again, carbon are the black with 4 holes, and chlorine is the green ones. So and it looks like each chlorine has 3 lone pairs attached to each. Oh, our drawing should look like, or not our drawing, our structure. Right. Yeah, that's a perfect one-to-one. This is what our built structure should look like in the end. Here's just to make sure there are no empty holes in the balls. So if there's an empty one, it means you probably used the wrong one, given that your math is right. And then here it's showing you how to take a picture of it. And then here, number 8, it says determine the number of bonds and lone pairs that are around the central atom. Then record the data on table 2 under the column titled bonds and electron pairs surrounding the central atom. So how many bonds surround the carbon? If I can stop dropping my model, that'd be great. So what would I write? Wait, I keep forgetting to use the table. Okay. So number of valence electrons, like we counted in the beginning, should be 32. Number of total number of atoms and set of lone pairs surrounding central atoms. How would they word it like that? Um, yeah, that's a weird way to word it, but fine, whatever. So we know this structure doesn't have any lone pairs. But it does have 4 bonds. And then using figure 11, we have to determine the molecular geometry. So ours looks like which one? My money would be tetrahedral. It has 4 things attached, and none of them are lone pairs, so it's the one that matches. And repeat steps 4 to 9 with the remaining substances and upload images into 4 through 20. And here are some hints. Some have more than one central atom, but you won't have to describe the geometries. Or multiple geometries will not need. Well, okay, I gotta slow down. Some substances have more than one central atom. Multiple geometries will need to be described. So I guess for this middle column, if I had two atoms, 2 central atoms, I would put atom 1 and then atom 2. Or yeah, 2. Don't put atom 1. Put the proper name of the element. I'm just using this as a simple example. Some substances have a charge with the brackets, like I showed you guys in the beginning. Some have resonance. So resonance means is that the structure can be drawn multiple different ways. It's usually one or two. I believe the first page had an example. Uh, I'll go over it. Most but not all of the substances fulfill the duet and octet rules. So, like again, hydrogen doesn't follow octet. It only wants two things, or two valence electrons, or in other words, it only wants one attachment. So let's show the resonance structure. I'm going to clear the page. Here. Okay, here it is. This is what it means by resonance structures. So you can see how this person drew the oxygen on either side, meaning the double bond could have been on left or right. So what the lab wants you to do is if this happens again in any of the other structures, it wants you to do this. So write each version of the resonance structure. Pretty simple. Does that make sense? Okay. So let's go back. Let's do H2O2. Taking apart my structure right now. So give me one sec. Okay. Hydrogen should know it's one. And we have another one. Oxygen is six. We have two of them, which gives us a total valence of 14. We have a hydrogen and a hydrogen. So this is an interesting case of two central atoms. Oxygen, or both oxygens are working as our central atom here. And then just go ahead and create our bonds here. Remember hydrogen, only one bond. We have this middle one. So let's count. Two, hydrogen's happy. Two, hydrogen's happy. Two, four, six, eight. This oxygen works. Then two, four, six, eight. So everyone obeys the octet. And then did we use the same amount of valence electrons that were given? 2, 4, 6, 8, 10, 12, 14. Yes. All right. So let's put this in our table. So we have a total number of 14. And then it says total number of atoms, 2 central atoms. And then I'll just put oxygen 1 has 2 pairs, or let's say bonds. And then how many lone pairs? 2 lone pairs. And then we could write the same thing for the second oxygen. Because it's the same. It's the same. There's nothing to add to that. Okay. Let's see. Structure. Interesting. Where is here it is. So for oxygen 1, let's highlight it first. So for oxygen 1, what would that look like? Which geometry is the most similar to this first oxygen? I don't know if that would help. So you have 2 lone pairs and 2 attachments. So it's actually bent. And for the other oxygen, because it's the same, we can also rule that it's also bent. So now it's just time to build the structure. All right, so yours should look something like this. Yeah, very accurate. So now all left to do is take a photo of our structure that we built and then upload it. So this is number 3, 4, 5. So dihydrogen dioxide would be photo 6. All right, I'm gonna clear. So how do you, how does everyone feel on the lab as a whole? Is there anything you don't understand? So we'll do one more together. Let's do NH4. One is charged. All right. So first order of business, counting. Yay, fun. Uh, nitrogen has how many valence electrons? 5. And hydrogen has a single one, but there's 4 of them here. So 1 plus 1 plus 1 plus 1. But remember this charge. Do not forget about the charge, please. I would hate for you to lose points because of this. So it's going to be -1. Because remember, positively charged means you're removing an electron. So in total, we should have 5, 6, 7, 8, 9. So 8. 8 valence electrons. So now let's draw this. We have nitrogen here. 1, 2, 3, 4, 5. And then we have 4 hydrogens. And they all like to be connected to a single element. So let's count. 2, 4, 6, 8. And then we have this single electron, making it 9. But remember, we only have 8 electrons to work with because of the total valence that we counted. So in this case, we're actually able to remove that lone electron. So that a single electron on that nitrogen shouldn't be there at all. So now we have 8. Nitrogen has 8 around it. It's filled the octet. All the hydrogens are happy. The only thing left to do is the brackets. And there's our drawing. So next order of business. Which structure is this? It's a tetrahedral. The nitrogen is the only central atom in this case, so tetrahedral is the molecular geometry. So nitrogen has 4 bonds, 0 lone pairs. And then the geometry was tetrahedral. And then all that's left is to draw the structure. So nitrogen uses the light blue ball. It should be the only one that came in your kit. So that's what I'm going to draw. And that's it. No lone pairs here, so we don't have to use the paddles. And make sure you're using the hydrogen ball is the single hole, tiny one. And take a photo and then upload it to, I believe this is number 14. So that's how this lab is going to go. How is everyone feeling on it? Is it pretty easy? Does anyone have any questions? Okay, so I'm gonna let you guys go and do the rest of these on your own. If you do have questions about the lab, if one's giving you trouble, feel free to contact me. And just a quick reminder that the chapter 13 lecture is already up in Canvas. And another reminder that this Saturday your exam is going to go up and that you're allowed a cheat sheet, 1 page front back. And also the practice exam should be going up soon. Oh, and for the exam, I believe you have 1 week to finish it. So this Saturday it opens, and then the following Saturday is when it's due. Other than that, I have nothing else for you guys.